We'll proceed in tedious calculus problems. Tedious calculus problem, the kind of scenario where we are proceeding and we are hopeful that we will take very different scenarios also. But right now, we are tackling calculating the weight. If I know calculating the weight in a sense, calculating the weight. So calculating the weight in a sense that if I have a density of a material, if I know density of a material, then how I can calculate the weight? Density into volume is weight. Okay, so if I have a material, then if I know the density of the material, if I multiply by the volume, then it gives me net weight. Like I have a material, I have two materials. Okay, I have two materials. Okay, one is this material and one is this material. Okay, they are both things. If someone see through a perspective of a fruit, then they are same thing. One is ripened and one is little bit raw. Okay, eatable though. Anyway, the density of this is different. Density of this is different. If I multiply this density by the volume, I get the net weight. If I multiply density of this by volume, I get the weight of this material. Understandable, right? Okay, so very nice it is. But someone would put question here that density is not the same all around. Density is not the same all around. If you see the cover section, the skin section, density is different. If I cut it, then inside that there are seeds and there are pulp. Everywhere density is different. Then Mr. Tell me how you can calculate the weight of this material when density is different. Then people would ask, can you give me in algebra what is the formula of density? If you give me the formula of density, even though your density is variable, still we can calculate the volume. So anyway, we have come to a conclusion that we can have dimensionability. If we see that from the dimensionability point of view, there can be 2 dimension, 3 dimension, 4 dimension, 5 dimension, 6 dimension. Dimensionability comes into the picture when we add independent and dependent component. Like if I see here, if I see this shape, then at any point x comma y comma z, there is a density. And in that sense, density is dependent upon volume. X, Y, Z is a point that is called volume point, whereas density is dependent upon the volume. Anyone would say this is 4 dimension question. X, Y, Z being independent and density is being dependent. In that sense, if someone talks about the net weight, then it is density d of x, d of y, d of z, and then limit of x, y, z will give the net weight. But this is something tricky. Any problem, better we go by fundamentals of the any technology. So calculus is a technology. Fundamentally, it is in two parts: integration and differentiation. Integration is multiplication, differentiation is division. In multiplication, one is multiplication means there are two items to multiply. Okay, basic multiplication, it has two items to multiply. One is called dependent and one is independent. Density is dependent and volume is independent. In that sense, the net multiplication will be density into volume. If dependence and independence is there, then this multiplication will fall into integral calculus. Now, the density into volume will become d into d of v. Density being capital D and volume being d of v, small d of v. This is integral calculus. A small d, we keep it to signify it is not normal multiplication. It is integral calculus. Someone has to calculate this multiplication density into volume by drawing a graph where volume is independent component x-axis and density being y-axis. Then draw a graph density versus volume and then calculate the area. If someone calculate the area, indirectly it is multiplication only. But normal multiplication will give the area only when it is rectangle. Otherwise, integral calculus will give the area. So net idea where this multiplication and integral calculus, they come in sync with each other. What point they are same. Where we calculate multiplication by calculating the area, where one side and there is another side, then they fall at same place. Multiplication and integral calculus, they come at same place when we are trying to find the result by calculating the area of a graph. Okay, but in normal multiplication where both are independent to each other, it forms a rectangle and area is simple multiplication. Whereas one is dependent upon another, then it may not form rectangle. Still, we find the multiplication by calculating the area. That is integral calculus. So density into volume. When density is dependent upon volume, the net multiplication will come through calculating the area. That is density d of volume. It has some fixed way to find the area. Okay, some basic polynomial, we know the area. From there, we kept calculating for other thing, and we know the integral calculus or calculating the multiplication through area for basic shapes like trigonometry, logarithmic. We know, and then if two are multiplied, then how it will be, that is kind of multiplication rule, chain rule, many things, basic thing we know. Through that we try to calculate the area. What is the net aim of doing multiplication or integral calculus is to calculate area, to calculate the abstract multiplication. That is the net aim. Anyway, we saw Jacobian. Jacobian in the sense, what is the net weight, that is density, that is function over volume, small f, and in braces v, braces close, function over volume, d of v, fv, d of v into d of v will give the net weight. If it gives the net weight, fv dv, okay, then d of v, we call it d of xyz volume. D of v volume comes through, if it is Cartesian coordinate or whatever it is. Volume means it has three sides. It corresponds to cube, it corresponds to sphere, anything that has three sides. If it is Cartesian, then we say d of cubical, cubed, xyz cube. D of volume is d of xyz cube. D of area is d of xy plane. D of a line or curve is d of x. D of volume or d of xyz is same as d of xyz cube by d of r theta phi cube into d of r theta phi cube. Simple multiplication. 2 equal to 2 into 100, 2 equal to 2 into 100 by 100. Simple. Okay, so d of xyz cube is same as d of xyz cube by d of r theta phi into d of r theta phi. Okay, so what is d r theta phi? R theta phi is method of substitution. We have taken x equal to r sine phi cos theta, y equal to r sine phi sine theta, z equal to r cos phi. You took a spherical coordinate system. No, it is a coincidence that it is also spherical. We will not go by anything that is related to spherical. Understandable? I am just saying that x equal to r sine phi cos theta, y equal to r sine phi cos sine theta, z equal to r cos phi, where r, phi and theta all are variable. So 3xyz is their three variable. In method of substitution, we will take three variables there also. Okay, dx, dy, dz cannot be dxy cube. Can some people can write as dx, dy, dz since they are orthogonal, but it cannot be changed as x equal to r sine phi cos theta, then dx equal to this much, y equal to r sine phi sine theta, then dy equal to this much, z equal to r cos phi, then dz equal to this much. Not possible because two variable are there in z. In y three variable are there. In x three variable are there. So we cannot say dx equal to. I have to do division with some of one particular variable. So it is not possible. Altogether, I have to take differentiation. That is d of xy cube by d of r theta cube. That is if I have. Okay, so how it is? Okay, we say that r x equal to r sine phi cos theta, then x equal to h r theta phi. H is a, I'm sorry, x equal to g small g bracket open r theta phi, r comma theta comma phi. H g is a function over r theta phi. If it is a function over r theta phi, there is an algebraic equation that is x equal to r sine phi cos theta, y equal to r sine phi sine theta, y equal to h r theta phi, y equal to is a function over r theta phi. Okay, z equal to r cos phi, z equal to alpha r theta phi. I can include theta also here also, means x, y, z are function over r theta phi. Anyway, I mean in the past video we have talked about it. So if I take a x, y, z, if I take r theta phi coordinate system, this is theta x axis, this is r y axis, and this is z axis, that is phi. This correspond to cubical region. If I map it to x, y, z, this is x axis, this is y axis, and this is z axis, then this cubical shape would map to a spherical shape. Why? How you can say that cubical? How you are so confident that cubical shape will in r theta phi plane will map to a spherical in x, y, z? Because I have taken the method of substitution relationship like that only. X equal to r sine phi cos theta, y equal to r sine phi sine theta, z equal to r cos phi. Okay, in that sense, it is more or less look like if there is a z, then with vertical there is an angle called phi. Then it is z cos. I'm sorry. If this is r, then r cos phi is z. Makes sense? If this is phi angle and this is vertical, r cos phi is vertical, r sine phi, and then cos theta is x, r sine phi sine theta is y. It looks like that, but not required. We will do some visualization. Visualization is not required here. Anyway, I don't care that cubic. I know it is cubical in r theta phi, but it will map to a spherical. I don't care actually. Anyway, now dxyz cube by, see, I'm saying dxyz cube, dxyz cubical to or 3d to dr theta phi means if I take a volume, if I take a cubical volume of 1, if dy by dx means if there is a 1 unit of change in x brings how many unit of change in y, where y is dependent upon x, y is related to x, both are not independent to each other. In that sense, if I make 1 unit change in x, how many unit of change in y we see, where y is related to x through some algebraic equation. Similarly, d of xyz cube by d of r theta phi, now it is 3d. If I make 1 unit of volume change in theta r phi cubical section, how many unit of volume change I see in xyz? If there is a cubical here and there is a cube in r theta phi, if I make 1 unit of change in the cube at any moment, okay, suppose there is a cube that is kept here and cube sides are r theta phi. Similarly, here there is a shape, okay, in XYZ plane, and it has a volume. What is the volume? That I don't know. But in this r theta phi plane, where the sides are r theta and phi and cube is r into theta into phi, if I make one unit of change, either it is expansion or contraction, if I make one unit of change in the volume, how many unit of volume change I see in the XYZ plane? They are tied to each other. X is dependent upon r theta phi, y is dependent upon r theta phi, z is dependent upon r theta phi. In that sense, if I do any change in r theta phi, similarly there will be change in xyz also, because they are tied. Xyz is dependent upon it. Okay, once I saw that there is a robot. There is a big robot I saw. Okay, and big robot is tied to a small robot. They look very similar. There is a small robot and there is a big robot. They are exactly same. Only thing is difference in size, but they are exactly same. If I rotate head of the small robot, then bigger robot's head is rotating. If I shake the hand of the small robot, then big robot's hand is shaking. Means big robot is dependent upon a small robot. Small robot is independent. Big robot is dependent. Big robot is XYZ, small robot is theta or phi. If I make any change in a small robot, big robot is changing. Similarly, we have theta or phi. If I make any change here, XYZ volume will change because XYZ is tied with the R theta phi. If I make at any moment, if I make one unit of change, how many unit of volume change I see in XYZ? That is dxyz cube by d theta r phi, r theta phi. Okay, for that we saw that it is nothing but if I take any point P, that is r theta phi, that P point is mapped on xyz as P only, but that point will be xyz, or G r theta phi, comma H r theta phi, comma alpha r theta phi. Now in the P, I take one distraction, one delta theta increment along theta axis, delta r increment along r axis, and delta phi increment along phi axis. In that sense, we have 4 points now: P, P1, P2, and P3. Similarly, we have 4 points here: P, P1, P2, and P3. P3 along z axis. One is along x axis. I'm sorry, it may not be exactly in the z axis. Depends upon the mapping. But whatever it is, certainly there are 4 points: P, P1, P, P2, and P, P3. Okay, now if I want to know how much is the volume change I am making, delta theta, delta r, delta phi. Delta theta, delta r, delta phi at point where it is r theta phi, if I make a small volume increment of delta theta, delta phi, delta multiplication, delta theta into delta r into delta phi, at any point here, that is g theta r phi, comma h theta r phi, comma alpha theta r phi, how much volume increment I see because of delta r theta phi. That volume increment by delta theta r phi is exactly dxyz cube by d theta r phi as per the fundamental of differentiation, and that is P1 cross product with P2. Now if I take in vector form, if I know two vector, if I do cross product, I get the area, and area vector will be perpendicular to the surface, so it will come in the z direction. Now if I want volume, then I cannot do further cross product because it will result in 0. Then we do dot product, and it is called triple scalar product. So P1 cross P2 whole dot product with P3 will give the net volume. Through array, through the vector, we can calculate the net volume. So d of xyz cube by d of r theta phi is same as P1 cross P2 whole dot product P3 divided by delta theta, delta r, delta phi. It is same as P1 by delta theta cross P2 by delta r whole dot product P3 by delta phi. Anyway, we settled it down, and it came as r square sine phi, more or less, and it was mind blowing. At least I have not seen, at least I have not seen this in any of the book that someone has dared to calculate the Jacobian 3D in this fashion, and this explanation is not there anywhere else, and it is r square sine phi. Anyway, we proceeded in calculating the density weight, that is density into d of v. Density is x square plus y square plus z square plus 3. This is what density function we have taken, and it will certainly, it is not going to match the guava, because at origin density is lower. Certainly density is lower here also, but it will grow as we go in xyz. So that much, that is not exactly matching guava. It would map some fruit, I believe so, that is x square plus y square plus z square plus 3 is the net kind of density function. X square plus y square plus z square, if you see the sphere, it is r square plus 3 r square sine phi d theta r phi will break into d theta dr d phi. Now altogether it comes as r to the power 4 r to the power 4 plus 3 r to the power 3 bracket close sine phi. We can settle down sine phi, and we did it. Sine phi will become cos minus cos phi. Now cos phi, phi is from where to where, I don't know. Now the limit is v1 to v2. The limit is v1 to v2. Limit is v1 to v2. If we transform into 2D, right, where x-axis is volume and y-axis is density. Now, as per the two-dimensional integration, it is density, that is function over volume, into d of v. Integration limit is in volume x-axis v1 to v2. v1 to v2 is the net volume. In that sense, it is v1 to v2. Okay, that is the volume. But v1 and v2, they will come in r theta phi. How they are related? I can now v1 to v2, I can break it in r1 to r2, theta 1 to theta 2, phi 1 to phi 2. This I can break, and dr theta phi plane will break into dr d theta d phi. Altogether it will come as, anyway, we have done it. So it is r to the power 4 plus r to the power 3 by r 3 into r to the 3 into r square, r to the power 4 plus 3 into r square bracket close, minus cos phi. Sin phi d phi is minus cos phi. Phi is from where to where? Now someone would say it looks like a spherical coordinate system. So phi will be 0 to pi and r will be 0 to a is being the radius of the sphere, and theta is 0 to 2 pi. But that is not fair as far as method of substitution is concerned. We don't know what it is actually. So let's try our best. We have x square plus y square plus z square equal to a square. X square plus y square plus z square equal to r square equal to a square, r square equal to a square. Okay, in that sense, r square equal to a square. Now r can be minus a and a, r can be minus a and a, r square equal to a square, r equal to plus minus a. I believe it is all right. R equal to plus minus a means if r I keep minus a, then again it becomes a square, all right, or a square, means r varies from minus a to a, r varies from minus a to a. Okay, this is one limit I find. Another is x equal to r sine phi cos theta, y equal to r sine phi sine theta, x square plus y square equal to r square sine square phi. I believe it is all right. So x square plus y square equal to r square sine phi, x square plus y square. If I see that there are three functions here, there are three functions here. One function is x square plus y square plus z square. X square plus y square plus z square equal to a square. A is radius. A looks like this is radius of the sphere. Why I am saying like this? Because I have taken a shape of a sphere. Okay, I have not taken shape of the sphere. Okay, I don't know how you are saying sphere every time when there is no concept of the sphere. But still, x equal to r sine phi cos theta, y equal to r sine phi sine theta, z equal to r cos phi, x square plus y square plus z square, indeed it will come as r square 1. Okay, so that will come as r square 1. So x square plus y square plus z square. Okay, so anyway, so that we are trying to calculate. Okay, so first is we will see how much is the kind of, anyway, leave it. So this is the way we have to calculate the kind of we have to calculate the limit. So concept is to calculate the limit from this fundamental. Anyway, so okay, so x, I'm sorry. Okay, so this is what we have done, which will go from where to where. Anyway, okay, so that is the method of substitution we have taken. Anyway, but at the end we are trying to calculate the volume of a sphere only. Volume of a sphere only. How you say like that? Because at the end you have to specify what is your volume. Density into volume. What is your volume? Volume is, indeed it is a sphere where x is from minus a to a. Why? Now if I have a sphere, then it has a radius. I am not deviating from anywhere else. Actually, I am trying to calculate the weight of a sphere. Weight of a sphere where x is x, where the radius of the sphere is a. If I see the x, y, z, then what is your equation of the sphere? Equation of the sphere is x square plus y square plus z square equal to a square. It has no relationship with the x square plus y square plus z square equal to r square that we took in method of substitution. What sphere we have taken, that is x square plus y square plus z square equal to a square. If that is the case, then z equal to square root of a square minus x square minus y square. Z varies from minus to plus. Okay, minus a to plus a, that is not true, because z in a sphere is dependent upon x, y, z. X, I'm sorry, z is dependent upon x, y. We will see it little minutely. Okay, consider this is xy plane. Consider this is xy plane. If this is xy plane and this is a sphere that I keep like this, or this sphere is centered at the origin, then xy plane will cut this sphere at the middle. If I take any x comma y, their z will be different. If I go with another x comma y on the xy plane, z will be different. If I take a cube, if I take any x comma y, the z will be constant. That is the cube. The height will be constant everywhere. So z is not dependent upon x and y within certain range. But if I take a sphere, then if I cut xy plane here, and then half of the sphere, if I keep it on xy plane, different x comma y, height is different. Z is dependent upon x and y anyway. That is z. Now if I cut it half and keep it on xy plane, and then if I draw the boundary of this on xy plane, it will make a circle. Circle radius is again the radius of the sphere only. But if it is a circle, then again y is dependent upon x. Y is not independent. Only x is independent. X is minus a to a. Y is minus square root of a square minus x square to square root of a square minus x square. Z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. So the volume V1 to V2 in Cartesian coordinate, I can break it as Z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Y is minus square root of a square minus x square to square root of a square minus x square, and then x is minus a to a. Now this I have to transform in r theta phi. So through the sphere equation, we have x square plus y square plus z square equal to a square. Through method of substitution, x square plus y square plus z square equal to r square. So r square equal to a square. R is plus minus a. So r will vary from minus a to a. One limit I have found it. Another is x equal to r cos phi, r sin phi cos theta, y equal to r sin phi sin theta. If this is the case, then x square plus y square is a square, or x square plus y square equal to r square sin square phi. Cos theta sin theta will go away. Okay, if that is the case, then y equal to y square equal to a square minus x square. It will come as a square. A square equal to sin square sin r square sin square phi. Sin phi equal to a by r plus minus. Sin phi is a by r plus minus. If plus minus means r, if I keep it as a, that is the limit of r, a, then it will become plus minus 1. Then plus minus 1 sin phi means phi is from minus plus minus 1 minus pi by 2 to pi by 2. This kind of explanation probably will not get anywhere else. So phi is the angle. If I think the phi is the angle, then phi angle will go from the origin. The phi angle will go minus pi by 2 to pi by 2 this way. Or someone can transform it 0 to pi, whatever comes to mind. But it will have pi by 2 to pi by 2. This is how it is. So minus pi by 2 to pi by 2, radius is minus a to a. What about theta? Theta. Anyway, y equal to r sin phi cos theta. X, y equal to r sin phi sin theta. Y by x equal to tan theta. Theta equal to tan inverse y by x. Okay, y equal to square root of a square minus x square. Tan inverse square root of a square minus x square by x. When x is minus a, then it will resolve into minus 0, minus infinity rather, minus infinity. If x equal to, x equal to minus a, x equal to minus a, then it will be minus 0. X equal to minus a to plus a. If someone keeps x equal to a, then it will be plus 0, or simply theta equal to tan inverse y by x. Tan inverse y by x. So one location x is minus a, then y is 0. X is a, again y is 0. So minus 0 to plus 0, tan inverse, that will result in 0 to pi, or pi to 0 rather, pi to 0. So theta is pi to 0. It is analogous, right? If it is a circle or a sphere minus a to a, then if I consider this as theta, then it is 0 to pi only, not 2 pi. A back to a will be 2 pi. So theta is pi to 0. Pi is minus pi by 2 to pi by 2. And radius is minus a to a. Okay, now someone can solve r square, r to the power 4. Now r to the power 4 plus 3r square. And we have minus cos phi dr d theta. Minus cos phi, if someone makes phi as minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. It resolves in 0. Okay, so looks like it is 0, but that is not true. Okay, so we have to do something more trick on it. Okay, so pi, how we found the pi? Pi we found through the x square plus y square r square sin phi. X square plus y square is a square equal to r square sin phi. Sin phi is a by, sin phi is a by r. So plus minus 1 minus pi by 2 to pi by 2. If it is coming as 0, If it is coming as 0, then how I can solve it? Not possible. Anyone would say not possible. Okay, if we are taking a sphere, then if it is coming, anything is coming as minus pi by 2 to pi by 2, I can I can make it 0 to pi by 2. Later I'll multiply by 2. Being a sphere, it will be congruent. This is how it is. Bear with us. Okay, similarly, radius is minus a to a. I can make it 0 to a multiplied by 2. Okay, then multiplied by 4. Outside multiplied by 4. Pi is 0 to pi by 2 and r is 0 to a. Theta is pi to 0 or 0 to pi. Makes sense? Multiply by 4. Okay, because half we have taken. This is the how it is. So cos pi 0 to pi by 2, it will come as 1. Pi by 2 is 0, 1. So as it is, 4 I have kept outside. Now r to the power 4, r to the power 4 plus 3r square. It will resolve in r to the power 5 by 5 plus r to the power 3. 0 to a to the power 5 by 5 plus a to the power 3. Then d theta, pi to 0 means pi. This is how it is. 4 pi will come as 4 pi, 4 pi, 4 pi a to the power 5 by 5 plus a to the power 3. This is the net. What we had calculated earlier with the when it was a spherical coordinate system. With a spherical coordinate system, everything was same like this only. Limit were different. Radius was 0 to a, pi was 0 to pi, and theta was 0 to 2 pi. If someone settle it down, cos pi uh, cos pi 0 to pi means 2. 2 will go outside. Radius is 0 to a. It will be same as a to the power 5 by 5 plus a to the power 3. Theta is d theta is theta 0 to 2 pi. Again 2 pi, 4 pi, same reason. Okay, so this is how we settle method of substitution. But main idea was to go with the Jacobian. Anyway, we will see more into the clarifying the limit because limit it looks like cumbersome. It is complex. So we will do more in satisfying the how we go with the limit settlement. So we will take more example. More example will give more clarity into the limit settlement. Not far away. I am not running away from this example. We will solve it with 2D Jacobian also. We have solved it with 3D Jacobian. Then can we use 2D Jacobian to solve it? We'll try. It is 3 dimension. Still we will use 2D Jacobian to solve it and that we will try. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.